Kobita Fukonn Baido, respected HOD of Nazira College, Dr. Jiten Fukonn sir, IQAC coordinator Surajit Soikia sir, and all the respected faculty present here from Nazira College and Gorgaon College, my dear students from both Nazira College and Gorgaon College. Today, I, Sujata Gwala, on behalf of the organizing committee, would like to welcome you all to this virtual or online talk organized by Department of Mathematics, Gorgaon College, in collaboration with Nazira College and IQAC, Gorgaon College. So, we all know today is International Mathematics Day. We celebrate this day every year on 14th of March. It is celebrated across the world to highlight the universal importance of mathematics in science and technology and everyday life. And recognized by UNESCO, this day promotes mathematical education, innovation, and global collaboration while honoring the contribution of great mathematicians throughout the history. And it emphasized the role of mathematics in solving many real-world challenges and foster loves for mathematics, breaking the usual stereotype we have regarding mathematics. And actually, we celebrate this day to encourage basically the young minds to explore this field of mathematics. So in this auspicious day, we intended to celebrate the day, and we have invited an eminent graph theoretist, mathematician, Professor Ankur Bharali sir, in this occasion. So we will be having an hour-long online talk, and he will share his knowledge and insight on the theme Mathematics as Muse, the Artistic Symphony of Geometry and Enumeration. So I thank you all again for being with us today in this evening. And now I'd like to read out, first of all, I'd like to read out the agenda of today's program. The agenda is as follows. First of all, we will be having greetings from the esteemed principal sir. After that, we will be having welcome address by respected HOD of Gorgaon College, Dr. Kobita Fukonn Baido. After that, I would like to take the opportunity to introduce the resource person, and then we will have resource person's speech followed by an interactive session, and after that we will close the session with a vote of thanks. So without further delay, I respectfully invite our esteemed principal, Dr. Sebasachie Mahanta sir, to say a few encouraging words. Sir, it's over to you.
Thank you so much, Professor Sujata Gwala. A very good afternoon to you all. International Mathematics Day that has been organized by our Department of Mathematics, Gorgaon College. Respected Dr. Kobita Fukonn, HOD of Department of Mathematics, Gorgaon College. Vice Principal, Mr. Digonto Kumar of Gorgaon College. Dr. Jiten Fukonn, HOD of Department of Mathematics, Nazira College. Dr. Surajit Soikia, Coordinator, IQAC of Gorgaon College. Respected teachers and my dear students, and I would also like to welcome today's resource person, Dr. Ankur Bharali, Professor in the Department of Mathematics, Dibrugarh University, who would be speaking on Mathematics as Muse, the Artistic Symphony of Geometry and Enumeration. And at the very outset, I would like to welcome you all to the session that has been organized by our Department of Mathematics, Gorgaon College, and I would like to appreciate the endeavor that has been taken by the department. As our anchor, Dr. Sujata Gwala, has rightly said, that we have been observing the 14th of March every year since 2019 as International Mathematics Day to raise awareness about the importance of mathematics in tackling the global challenges, as well as to estimate the contribution that has been made by mathematics in the field of science and technological advancement. আজি বিশ্ব গণিত দিৱস আৰু বিশ্ব গণিত দিৱস এই দিৱসটি ইউনেস্কোয়ে 2019 চনৰ পৰা 14 মাৰ্চ তাৰিখটো প্ৰতি বছৰে উদযাপন কৰি আহিছে. This day has been observed as Pi Day also, as the approximate value of pi is 3.14, 14.3. 14 March, our 3 number মাহ গতিকে এটো পাই ডে হিচাপেও উদযাপন কৰি অহা হৈছে আৰু এতিয়া এটো ৰাষ্ট্ৰীয় গণিত আন্তঃৰাষ্ট্ৰীয় গণিত দিৱস হিচাপে উদযাপন কৰা হৈছে এই কাৰণে যে গণিতৰ বিভিন্ন ভেৰিয়াছ ফিল্ডছত এৰিয়াজত গণিতৰ ম্যাথমেটিক্সৰ কন্ট্ৰিবিউশন কি role in tackling the global challenges and also to contribute to achieving sustainable development goals that has been determined by the UN. That the target of achieving sustainable goal has been fixed as 2030. গতিকে গণিতে কেনেকুৱা ধৰণে কন্ট্ৰিবিউশন কৰিছে সেই সন্দৰ্ভত এটা এৱাৰনেস এটা সজাগতা সৃষ্টিৰ কাৰণে আন্তঃৰাষ্ট্ৰীয় গণিত দিৱস উদযাপন কৰি অহা হৈছে আৰু গণিতৰ আসলতে প্ৰত্যেকটো ক্ষেত্ৰত গণিতৰ বা ম্যাথমেটিক্সৰ যেটো কন্ট্ৰিবিউশন আমি হেতু সদায় স্বীকাৰ কৰি আহিছো গণিত অবিহনে বিজ্ঞান আৰু প্ৰযুক্তিবিদ্যাৰ কোনো মূল্য নাই গণিত লাগিবই প্ৰত্যেকটো কথাতে গণিত লাগিব আমাৰ জীৱনৰ ডে টু ডে লাইফত লাগিব আৰু শেহতীয়াকৈ মই 2-3 দিন আগত এটা বাতৰি পঢ়িছো ডক্টৰ অংকুৰ ভৰালী তেখেতে হয়তো ক'ব এই সন্দৰ্ভত যে গাণিতিক সূত্ৰৰে ভগৱানৰ অস্তিত্ব নিৰূপণ কৰাৰ এটা প্ৰচেষ্টা চলিছে গতিকে আজি আমাৰ মাজত ৰিসোৰ্স পাৰসন আছে আই ওয়েলকাম মই তেখেতক ওয়েলকাম জনাইছো স্বাগতম জনাইছো অংকুৰ ভৰালী তেখেত এজন নাম থকা তেওঁ নাম জ্বলা তেখেত ম্যাথমেটিশিয়ান এজন গণিতজ্ঞ তেখেতৰ বক্তব্যই নিশ্চয় আমাৰ ছাত্ৰ ছাত্ৰী সকলক আমাক উপকৃত কৰিব আৰু তেখেতৰ মোৰ সাবজেক্টটো শুনিয়ে ভাল লাগিছে ম্যাথমেটিক্স এজ মিউজ দ্য আৰ্টিস্টিক সিম্ফনি অফ জিওমেট্ৰি এণ্ড এনিউমাৰেচন মই তেখেতৰ কন্ট্ৰিবিউশন বা তেখেতৰ কাম বিলাকৰ কথা শুনি আছো আমাৰ সুজাতা গোৱালাই ভালকে উল্লেখ কৰিব মই সিদিনা যেতিয়া এই কথাটো ওলাইছিলে মই তেতিয়া কৈছো যে আমাৰ ডক্টৰ অংকুৰ ভৰালীক আমাৰ ছাত্ৰ ছাত্ৰীৰ লগত অলপ ইন্টাৰেকশন কৰাৰ সুযোগ দিব লাগে যাতে আমাৰ ছাত্ৰ ছাত্ৰী সকল উপকৃত হ'ব পাৰে আৰু মই ডক্টৰ অংকুৰ ভৰালী ডাঙৰীয়াক মই আজি এই অনুষ্ঠানতে আহ্বান জনাইছো যে আপুনি অফলাইনটো আমাৰ কলেজলৈ আহি আমাৰ ছাত্ৰ ছাত্ৰী সকলক অকমান উপকৃত কৰিব বা ছাত্ৰ ছাত্ৰী সকলৰ বাবে কিবা এটা আপুনি দিয়াৰ কাৰণে আমাৰ যত্ন কৰিব মই আজি I welcome you all to this event and hope the event would be a very beneficial one for us and will be enlightened by the speech that would be delivered by Dr. Ankur Bharali. আমাৰ ডক্টৰ অংকুৰ ভৰালী ডাঙৰীয়াৰ বক্তব্যই আমাৰ সকলোকে উপকৃত কৰিব আৰু মই পুনৰবাৰ উদ্যোক্তা সকলৰ আন্তৰিক শলাগ লৈছো যে তেওঁলোকে আজি আমাৰ এই বন্ধৰ দিনটোটো আজি আমাৰ ফাকুৱা উৎসৱ তাৰ লগতে আজি বতৰ আমাৰ ডিব্ৰুগড়ত কেনেকুৱা নাজানো শিৱসাগৰত আমাৰ জয়সাগৰতো শিল পৰিছে গতিকে এনেকুৱা প্ৰতিকূলতাৰ মাজতো এই অনুষ্ঠানটি আয়োজন কৰিছে অকনমান আমাৰ এই বন্ধ উৎসৱৰ মাজতো শৈক্ষিক বিদ্যায়তনিক দেশত কিঞ্চিত আমাৰ ছাত্ৰ ছাত্ৰী সকলক কিবা এটা দিয়াৰ কিবা এটা আমাৰ তেওঁলোকক শিকোৱাৰ এটা অৱকাশ আনি দিছে তাৰ বাবে মই ডিপাৰ্টমেন্ট অফ মেথমেটিক্স আন্ডাৰ দ্য able leadership of Dr. Kobita Fukonn all the teachers and students there I appreciate their endeavor and I offer my sincere thanks and gratitude to Dr. Ankur Bharali. He has given the consent to participate in this session and join us as a resource person because as Kobita Fukonn told me that Ankur Bharali was also in leave but I think he arrived Dibrugarh today only and after that also তাৰ পিছতো তেওঁ আমাৰ লগত আজি সংযোগ হৈ আমাক এইখিনি সুযোগ দিয়াৰ কাৰণে আজি এই অনুষ্ঠানটি জিপাল কৰি তোলাৰ বাবে তেখেতৰ প্ৰতিও আন্তৰিক ধন্যবাদ আৰু কৃতজ্ঞতা জ্ঞাপন কৰিছো পুনৰবাৰ সকলোলৈকে ধন্যবাদ জনাইছো আন্তঃৰাষ্ট্ৰীয় মেথমেটিক্স ডেৰ বাবে সকলোলৈকে শুভেচ্ছা জ্ঞাপন কৰিছো আৰু আজিৰ অনুষ্ঠানটিৰ সামগ্ৰিক সফলতা কামনা কৰি এই অনুষ্ঠানটি আনুষ্ঠানিকভাৱে উদ্বোধন কৰা হ'ল বুলি ঘোষণা কৰিছো I declare the session is open. Thank you so much. Thank you.
Thank you, sir. Thank you very much for your informative and encouraging inaugural speech. And thank you for your continuous support and the suggestion you have been providing us to make such event a successful one. Dhanyawad, sir. Now, I would like to request Dr. Kobita Fukonn ma'am to say a few words in this occasion. Baidew, over to you.
শুনিছানে সুজাতা
হয় মেম শুনা গৈছে
শুভ সন্ধিয়া মই পোনপ্ৰথমে সকলোকে নমস্কাৰ আৰু সেৱা জনাইছো আজি আন্তঃৰাষ্ট্ৰীয় গণিত দিৱস 14 মাৰ্চ আজি আন্তঃৰাষ্ট্ৰীয় গণিত দিৱসত আমাৰ এই ৱেবিনাৰত উপস্থিত মই সকলোকে আন্তৰিক শুভেচ্ছা জনাইছো আৰু আজি ৰঙৰ উৎসৱ ফাকুৱালৈ সকলোকে শুভেচ্ছা জনাইছো আজি গড়গাঁও মহাবিদ্যালয় গণিত বিভাগৰ উদ্যোগত আৰু নাজিৰা মহাবিদ্যালয়ৰ গণিত বিভাগ আৰু গড়গাঁও মহাবিদ্যালয় আভ্যন্তৰীণ মান নিৰূপণ কোষৰ উদ্যোগত আয়োজিত আজি ৱেবিনাৰত উপস্থিত থকা সকলোকে শ্ৰদ্ধা আৰু সেৱা জনাই সকলোকে পুনৰবাৰ আদৰণি জনাইছো আজি অনলাইন টকত উপস্থিত থকা গড়গাঁও মহাবিদ্যালয় শ্ৰদ্ধাৰ অধ্যক্ষ মহোদয় ডক্টৰ সব্যসাচী মহন্ত ছাৰ অনলাইন টকৰ শ্ৰদ্ধাৰ সমল ডিব্ৰুগড় বিশ্ববিদ্যালয় গণিত বিভাগৰ প্ৰাধ্যাপক ডক্টৰ অংকুৰ ভৰালী ছাৰ শ্ৰদ্ধাৰ উপাধ্যক্ষ মহোদয় দিগন্ত কোঁৱৰ ছাৰ আভ্যন্তৰীণ মান নিৰূপণ কোষৰ সমন্বয়ক ডক্টৰ সুৰজিৎ শইকীয়া ডাঙৰীয়া আৰু নাজিৰা মহাবিদ্যালয়ৰ শ্ৰদ্ধাৰ শিক্ষকদ্বয় জিতেন ফুকন ছাৰ আৰু সুজাতা বৰঠাকুৰ বাইদেউ আমাৰ মহাবিদ্যালয়ৰ শ্ৰদ্ধাৰ শিক্ষকবৃন্দ আৰু গড়গাঁও মহাবিদ্যালয়ৰ নাজিৰা মহাবিদ্যালয়ৰ মৰমৰ ছাত্ৰ ছাত্ৰীসকল মই পুনৰবাৰ সকলোকে 14 মাৰ্চ আন্তঃৰাষ্ট্ৰীয় গণিত দিৱসৰ শুভেচ্ছা জনাইছো এই 14 মাৰ্চ আন্তঃৰাষ্ট্ৰীয় গণিত দিৱসটো আমাৰ 2019 চনৰ পৰা ইউনেস্কোৰ সিদ্ধান্ত মৰ্মে প্ৰতি বছৰে পালন কৰি অহা হৈছে যাতে আমাৰ গণিত বিষয়টো বিভিন্ন দিশত জনপ্ৰিয়তা লাভ কৰিব পাৰে তাৰ উদ্দেশ্য আগত ৰাখি 19 চনৰ পৰা প্ৰতি বছৰে বিভিন্ন স্থানত বিভিন্ন দিশত গণিত বিষয়ত উন্নতি সাধনৰ উদ্দেশ্য লক্ষ্যত আগত ৰাখি আমাৰ 14 মাৰ্চ দিৱসটো মানে আন্তঃৰাষ্ট্ৰীয় গণিত দিৱস হিচাপে পালন কৰি অহা হৈছে আৰু সেই উদ্দেশ্য আগত ৰাখি আমিও আজি যিহেতু ফাকুৱা হলি বন্ধ সেই গতিকে আমি এখন ৱেবিনাৰৰ পতাৰ সিদ্ধান্ত গ্ৰহণ কৰিলো আৰু এই ৱেবিনাৰখনলৈ যিসকল আমি সংযোগ হৈ আছো সকলোকে মই পুনৰবাৰ আন্তৰিক আদৰণি জনাইছো আৰু সকলোকে আজি আন্তঃৰাষ্ট্ৰীয় গণিত দিৱসৰ শুভেচ্ছা জনাইছো আশা ৰাখিছো ভৰালী ছাৰৰ বক্তব্যই সকলোকে উৎসাহিত কৰাৰ লগতে আমাকো অনুপ্ৰেৰণা যোগাব আমি বহুত কথা শিকিবলৈ পাম এই উদ্দেশ্য আগত ৰাখি আজি ৱেবিনাৰখন আৰম্ভ হ'ব অলপ এতিয়া ছাৰৰ বক্তব্য শুনিবলৈ পাম ধুনীয়াকৈ আৰু শেষত মই পুনৰ সকলোকে নমস্কাৰ জনাই পুনৰ আজি অনলাইন টকলৈ সকলোকে
মেম মাত শুনা পাইছে মিলি মোৰ মাত শুনা গৈছে নে
সুজাতা ঠিকে আছে দিয়া শুনি পাইছো
হয় হয় মোৰ নেটৱৰ্ক ইছ্যু হৈছিল চাগে ওকে ধন্যবাদ বাইদেউ thank you now let me introduce the resource to you I really feel honored and happy to introduce Professor Bharali sir so I think this is the first time I'm getting the opportunity to introduce Professor Bharali in front of you. So Professor Bharali is currently the Director of Internal Quality Assurance Center for Internal Quality Assurance and Center for Distance and Online Education of Dibrugarh University. He was the best graduate of his batch and he earned his master degree from IIT Guwahati, completed his PhD from Dibrugarh University. Chemical graph theory, spectral graph theory, and complex network are some of his area of interest. He has published numerous work, including research paper, book chapters, and books. Additionally, he has delivered many talks as a resource person, and he is really an outstanding speaker, actually. So apart from actively participating in different workshops and conferences and presenting research papers there, he has arranged a sizable number of seminars and conferences also in his capacity as an organizer. He has so far mentored about 7 MPhil students and 4 research scholars, PhD researchers, and currently around 9 students are actively working under him on research work in different research works. So, and moreover, in recognition of his contribution in collaboration, Professor Ankur Burali was awarded the Teachers Association for Research Excellence Award in the 2021 for working in collaboration with IIT Guwahati from the year 2021 to 24. So with this brief introduction, I would like to welcome Professor Varali. Welcome you again, sir, and we are eagerly waiting to hear from you on this topic. It's really a catchy topic, the artistic symphony of geometry and enumeration. So now I'd like to hand over the session to you. Over to you, sir.
Thank you, Sujata Gwala,
Thank
for
you,
the
sir.
kind words. At the very outset, I would like to thank all the organizers of this particular talk for inviting me, for having me in this on the occasion of International Mathematics Day. My profound gratitude to all the teachers of Gorgaon College and Nazira College for considering me to deliver this talk. And I welcome all the student friends also to this particular talk. Is it visible?
Yes, sir, it is. It is clear, sir.
Yes, sir.
Okay. Thank you. And I would also like to thank our principal, sir, for his kind words. Yes, definitely, I'll be very happy to be there in your college. I have missed a couple of occasions earlier due to some of the other engagements. Sorry for that. And for this occasion, I could not say no. That's why I'm here in this online platform. Anyway, so the topic that I have chosen for this talk is Mathematics as Muse, the artistic symphony of geometry and enumeration. So basically, my idea is to cover or convey my understanding about the subject that I have loved. I love the subject. I am pursuing this subject for last like 25 years of my life. And what I have understood, what I could interpret, that I shall try to convey through this 1 hour session. So how do we pursue mathematics? When we think of mathematics, mathematics is one of the, you can say, most successful endeavors of humanity. But whether it is a science or art, that is a very profound question that we need to address, because it basically has features of the scientific inquiry. It has the features of creativity. It has the features of intuition, which are very much relevant to the discipline of arts. So whether we should pursue mathematics as a discipline of science or as a discipline of math, as a discipline of science, that is a big debate. And what is the alternative way to proceed? What is science? So science is basically depends on, it's a discipline of reason, you can say. It is based on logical reasoning, structured problem solving. It has rigor, precision, and objectivity. Where arts is a discipline of, we can say, expression and creativity. So it involves creativity, intuition, aesthetics, all these things. So what we believe is that mathematics possesses both these features. We cannot ignore any of these features. Like we cannot ignore the logical aspects of mathematics. At the same time, we cannot deviate ourselves from the idea of or the involvement of creativity and intuition, something like that. All these features in mathematics. Now, again, the science and spirituality, as we know, arguably the two biggest, we can say, quest of inquiry of humanity. So where science depends on, you can say, imitation, logical reasoning, generalization, so on and so forth. Whereas the spirituality depends on, or spirituality is guided by belief, intuition, creativity, and so on. So we can say that mathematics is a living science. By a living science, what I mean that it possesses the features of science, but it is not 100%, you can say, devoid of creativity, 100% devoid of intuition. So this is a very typical example. In the 17th century, there was a very big debate going on. The people believed that we should have a knowledge-based society, a society that is basically driven by logic and the ability of problem solving, scientific thinking. And this particular Weger of Pascal, as we all know, is a famous mathematician, is basically, he was called the savior of Christianity because of this Weger. So what he has done is that he divided this into 4 blocks, where these 4 blocks are divided in like a 2x2 matrix, where believe in God, non-believe in God, God exists or not. So these are the criteria based on which he has computed this 2x2 matrix. So there you can see that if we believe in God and God actually exists, our benefit is infinite. If we don't believe in God, but the God exists, then we may face infinite loss. So that was his argument. And if we believe in God and God doesn't exist, then the loss is always finite. We will lose like couple of hours of time or like months of hours of our life. But if God doesn't exist, then we don't believe in God, then gain is also finite. So if we think logically from this 2x2, you can say matrix, what we can say is that it is better to believe in God because you never know, it may exist. So that's why here I just want to note down one very famous comment from our very own Ramanujan. An equation means nothing to me unless it expresses a thought of God. Why I'm saying this? Because you can see that mathematics is always pursued as a discipline which is both in the query of science as well as in the query of spirituality. So it is something like which is there in between maths and art. And what are the 4 philosophical foundation of mathematics? These are the 4 philosophical foundation of mathematics. Mathematics is basically, many of us believe that, and there is many school of thought that believe that mathematics exists independent of human thoughts. So there are some topics like topology, you can think of set theory. In a higher level, it doesn't devote its time for the human thought. It basically, some abstract ideas are there and we compute on that, we work on that. We use our logical ideas, we use our intuition to derive various results. Then also mathematics is a product of human activity. As we know that operation research is a very popular subject, is a very popular subject in mathematics that is coming out of the World War. Basically, the development of OR has been speed up because of the World War. Then yes, formalism is also a very you can say main feature of mathematics, because symbols and rules are the guiding force that will really lead to the conclusion in a mathematics. Then empiricism is another thing where we try to enumerate various observations, real life phenomenon using our mathematical tool. So let us first try to understand that how do we think about a problem in mathematics. Here you can see that a small girl is holding a hand fan, and she's asking why I am feeling a breeze on my face. So the answer is that the motion of the hand fan generated the breeze. So for that particular child, that query has been understood with this single sentence, that the motion of the hand fan generated the breeze. On the very next day, the same child sees that this last green field, there is some movement of this green-laden grasses, and it generates a, you can say, a gentle breeze. Then with the same argument, she said that because of the movement of the green-laden grasses, a breeze generates. But we know that this statement is not true. It is actually the other way around. Because of the gentle breeze, we are, having this movement of this grain-laden grasses. Now, how can you argue that her statement is not 100% correct? Earlier case, it was because of the movement of the hand fan that we feel the breeze, but here it is not because of the movement of the grasses we feel the breeze, but the breeze actually creates the movement of the grass. That how can we argue that her interpretation, her conclusion is wrong? So here comes the idea of what is called, how can you convince, what is called the counter example. So basically we have to give her a situation, you have to come up with a condition where she will be convinced to see that there is some breeze, but there is no movement of grain-laden grasses, or there is some grain-laden grasses, but because of the grain-laden movement of the grain-laden grasses, we do not have breeze. So either of this. So as you can see that if we go to a place where there is no breeze, but we can really pluck that particular tree or to have a gentle breeze. So that will be helpful to understand for the child that it is actually is the movement of the breeze that makes the grass to move. So this is what is called producing a counterexample to understand a particular concept better. So this is how we actually pursue an idea in mathematics. It may look very obvious, it may look very simple, but it is not actually the case all the time. So we should have better understanding, we should have deep understanding about the cause and the roots of the occurrences. Now, what is a paradox? When we talk about the logical statements always lead to a conclusion, but there are some statements where we may fail. For example, let us consider a statement. The statement is false. That is the statement. As you can see that I have quoted one statement here. The statement is false. Now the question is this quoted line, whether it is true or false. If I say that line is true, that means the statement is false. So it contradicts our conclusion. If I say that the statement is false, that means the statement is false, that means the statement is true. So it again contradicts our conclusion. So this is what can happen is that we may arrive to some conclusion which is not conclusive in any of the ways. So that is called basically paradox. And there are various paradoxes we have, and one of the famous paradox that we all know is the Barber paradox, But here I want to deal with, or I want to talk about another paradox, that is Laurus paradox. So this paradox was proposed by Protagoras. He was a philosopher. He was basically pre-Socratic era philosopher in the era 485 to 415 BC. So he made this statement that in Athens, Protagoras made a deal with a student. So it is supposed that Protagoras is very good in pursuing law. So he is a very well-known lawyer, but he has very little time to teach any student. So a student approached him and convinced him that, please teach me. I will pay fee once I win my first case. So that was the deal. The deal is that the student who is going to win the first case will pay the amount to the teacher, that is Protagoras. But the thing is that once the student graduated, he decided not to pursue law. So he said that I'm not interested to pursue, I'm not interested to be a lawyer, rather I want to be a teacher, or I want to be something else, musician, something else. So then the Protagoras thought that it is not a good idea because I'm not going to get the money in this case. So Protagoras come up with a very, you can say, innovative idea, and he sue him with the condition that since he is already a known student of law, he will only fight for his case. So the thing is that the student is going to fight against Protagoras. If the student wins, then he has to pay the fee to Protagoras as per the deal. If the student loses, then also he has to pay the fee to Protagoras. So this is a paradox, that is a famous paradox called the paradox of court. It is also known as paradox of professionalism. So it is used in various other communications and deliberations that we have in our day-to-day life. And it is basically known for, Protagoras is basically known for his famous quote that man is the measure of all the things. So it is the objectivity is a very subjective thing. That is the idea of Protagoras. He says that when we are saying that mathematics is a science, mathematics is an art, so these are very subjective idea. He says that man is the measure of all the things. So it is the man who is going to decide, or who is going to measure the content of a particular thing. So that is a very famous quote, and it is, referred in many other discussions in philosophical discourse and in various science and arts discipline. Now, let us go to the second dimension of mathematics, that is geometry. The first dimension that we have discussed is the logic. Logic is, you can say, the foundation of mathematics. Without logic, we cannot proceed in mathematics. And geometry is the art of mathematics. It is the way mathematics expresses its feeling. So here you can see two quotes, one from Plato. Says that geometry draws the soul towards truth. So the objective of mathematics is to find the final truth, the absolute truth, and the journey is guided by geometry. That is what he has said. And geometry is the art of drawing correct reasoning from the incorrectly drawn figures. So the figure that we draw usually are not correct. When we draw a circle, it is not a circle. But geometry gives you that, that skill to draw conclusion from that incorrectly drawn figure. So this is a first case, as Principal Sir has just mentioned, that it is because of the pi, that is 3.14, we are celebrating today what is called the International Mathematics Day. Now, this is pre-calculus era. This is a problem proposed by Archimedes. So he was trying to calculate the value of pi using the idea of perimeter of a circle. So if the radius of a circle is half, then we know that the perimeter of the circle will be 2 into pi into half, that is pi. So the perimeter of a circle of radius half is pi. So if I can calculate the perimeter of this circle, then we are done. That will be the value of pi. So what he has done is that he has drawn two kind of figures. He has drawn some triangles, divided the circle in some triangles, where these are some, in the first line you can see these are some triangles drawn inside the circle. And in the second line you can see that same thing is, we are doing the same thing, but for some triangles drawn outside the circle. And as we keep on increasing the number of times, the number of divisions, it is approaching the circumference of the circle. So the total, the length of this sides, total length of these sides will be equal to the perimeter of the circle. So the inner one, the first line will give us a lower bound to pi, and the upper, the second line will give us an upper bound to pi. In that way, he has computed up to 64 divisions. So he has made 64 partitions of the circle, and it come up with, Archimedes come up with this 223 divided by 71 less than pi. So that is basically for the first line, and this 22 by 7 is basically for the second line. Here is a very interesting observation. The interesting observation is what? That it is this particular computation was done in the pre-calculus era. So you can see this is actually an idea of limit involved in this particular computation. So when the number of division goes to infinity, actually the length of the sides of these triangles will be equal to the perimeter of the circle. But for some reason, he stopped himself at 64. And because of that, the calculus was, you can say, discovered by or invented by Newton 200 years after Archimedes. So there is a very small step that, or small point that Archimedes perhaps missed. And because of that, the humanity cost us 200 years. And similarly, how can we find the area of a circle? Again, the idea of limit is involved here, because pi is an irrational number. The idea of irrational number was not there. So how can you calculate the value of the area? So to do that, what he has done is that he divided it into 4 parts, like in the first figure, and arrange it in this way. So as you can see that half of the this semicircle, this perimeter will be what? Pi r, because as a whole this is 2 pi r. So half of the perimeter will be pi r. So if I connect this white and this gray, that will give us pi r. And the top of it, it is again pi r. And that side, this is equal to our radius, that is r. Now if we keep on increasing the number of partition, this will ultimately lead to something like a rectangle, something like this. So this is our pi r and this is our r. And as we know that the area of this rectangle is a into b. So pi r into r. That's why the area of a circle is pi r square. So it was an excellent way of obtaining the area of a circle in the pre-calculus era. So this is a very basic idea or a historical note on the idea of geometry, how the geometry beautifully explains our, you can say, queries, and it helps us to draw conclusion on various topics. Now, geometry can be very lethal also. Think globally. What is the shortest path between 2 points? Is it a straight line? That is the question. If we think globally, say for, yes, if it is a very simple thing, so for this particular figure, 2 points I have. What is the shortest part? This is the white line. White line is the shortest part. This is a straight line. This is the shortest part. Now, if I twist it with a condition that if this is a rubber, then I have to bend this rubber around that particular cone. So what will happen? This will be something like this. Now, what is the shortest part with this condition? So this is the shortest part with this condition. Now you are not allowed to connect these 2 points without going around the cone. So that the shortest part is no longer the straight line. Now, if you see a golf course, this is a golf course. You want to hit to this particular flag from this flag. So there you can see there are multiple paths. This is one path. This is one path. There is another path. So you can see if we impose some condition, if we impose some you can say constraint, then our conclusion may be different. So this is the beauty of mathematics. You have to start with a very feeble idea. Then we keep on constraining. If you can develop various complicated results for this for the same problem. So 2 points, many paths. That is the mathematical bleach. Now the question is how many? So how many comes with the idea of counting, idea of enumeration? If it is finite, we are in a very good shape. If it is not finite, then sometimes it is very difficult for mathematicians. How the geometry evolves, we can see that the first one is basically the idea of Euclid, then the spherical, then differential geometry. So this is the evolution of geometry, and things are going complicated day by day when we impose various conditions on these structures. Now, enumeration or counting. What do we mean by enumeration and counting? So these are two very famous quotes. One says that not everything that counts can be counted, and not everything that can be counted counts. So it's a very profound philosophical idea. যিটো আমি কাউন্ট কৰিব পাৰো সেইটো কাউন্ট কৰিবলগীয়া নহয় কেতিয়াবা আমি কিছুমান বস্তু আমি কাউন্ট কৰো সেইটো কাউন্ট কৰিব পাৰো সেইখিনি কাউন্ট কৰিবলগীয়া নহয় কিছুমান বস্তু আমি কাউন্ট কৰিব নোৱাৰো কিন্তু সেইখিনি কাউন্ট কৰিবলগীয়া ধৰি লোৱা ইমোশন হ'ব পাৰে ষ্টুডেন্টৰ কাৰণে মই কৈছো তোমালোকৰ ফ্ৰেন্ডশিপ হ'ব পাৰে তোমালোকৰ সেই বস্তুবিলাক কাউন্ট কৰিব নোৱাৰি কিন্তু সেইখিনি কাউন্ট কৰিবলগীয়া বস্তু কেতিয়াবা আমি ভাবো যে ধৰি লোৱা পইচা হ'ব পাৰে মাটি সম্পত্তি হ'ব পাৰে যিগুলা বস্তু কাউন্ট কৰিবলগীয়া নহয় কিন্তু সেইখিনি আমি কাউন্ট কৰো so not everything that counts can be counted and not everything that cannot be counted counts so this is a very famous quote it is known to be said by Einstein but in a separate book they mentioned that it is first mentioned by a sociologist called William Bruce Cameron I'm not sure about it so that's why I'm mentioning both the names and the second one is when I started counting my blessing, my whole life turned around. That is by Nelson. So these are very famous quotes, very deep. I mean, for students especially, you will understand as you grow old, you will understand the meaning of these sentences, these statements. There are layers of meaning of these statements. But the moral of the story, the moral of the discussion is that if it is not so important, why you are counting? Why you are counting? Why counting is so important? Then let us see why counting is important. Or let us try to go through the human history of counting. So this is the rock game. So what we usually do in our, you can say, medieval age that we used to count our cows, horses by mapping them with one stone at a time. So for every cow, we, you can say, keep one stone for every cow. In that way, the number of stone will give you the number of cows. Though the idea of number was not known. It is basically one stone mapping with one cow. In a modern science or modern mathematics terminology, you can say that it's a one-one mapping of the stone with the cow. So that's how the thing or the counting has been started. Now, how do you know that these ideas are actually can be used in modern mathematics? Say, for example, how do you know that a number is even or odd? How to distinguish? How many numbers here? If I want to count the number here, there are 6 stones. So it is 6. This is representing 6. Whether it is even or odd, how can you interpret that? Without knowing the idea, or without having the idea of division. So what we can do is that we can arrange them in this way, in 2 lines. If both the lines contain same number of stones, then it is an even number. If the second line contains one sort of stone than the first one, then this is an odd number. So for 5, you can see 1, 2, 3, 4, 5. So this is, you can say, this is an idea of odd number here representing on this particular slide. Now, how can you prove that odd plus odd is even? Again, using the rock game, how can you show that odd plus odd is even? Because if it is odd, then both the lines should have same number of stones. So this is the way. Here you can see that 5 plus 7. So this is odd plus odd. So these are arranged in this way, and now we have an even number. This shows that odd plus odd is an even number. How do you know whether a number is a perfect square or not? Like 4, 9, 25. How can you argue that? So this is one way to argue that. Say 4 will be arranged. So you have to arrange the stone in a way that number of rows will be equal to number of columns. If we can come up with this kind of structures, then we know that this is a square. For the third picture, you can see that it is like 15, 3 into 5. So this is not a square. The shape is a rectangle. Since the shape is a rectangle, so 15 is not a perfect square. পূর্ণবর্গ নহয় তাহলে এইটা কিন্তু যেটা হবে এটা পূর্ণবর্গ হবে 9 4 এনেকুৱা ধৰণে এটা কিন্তু 15 টো পূৰ্ণবৰ্গ নহয়. Now, how can you prove that 1 plus 3 plus 5 plus 7 plus ... twice n minus 1 is n square? How can you prove that? We know that n square is a perfect square. So I should be able to arrange these stones, 1 stone, 3 stone, 5 stone, 7 stone, twice n minus 1 in such a way that it will form a square like this. 1 stone, then L shape, 3, 1, 3, L shape, then 5, L shape, then 7, then L shape 9. So you can see, you can arrange any number of odd number of stones in this way. If I add all this, I will get a perfect square. So that's why 1 plus 3 plus 5 plus 7, this is equal to n square. How can you show that 1 plus 2 plus 3 plus 4, this is equal to n into n plus 1 divided by 2. So this is the way. This is 1 stone, 2 stone, 3 stone, 4 stone, 5 stone, like that. Now if I add the same number of stone, but in a different manner, what you can see is that there are n number of rows, but n plus 1 number of columns. So it is n into n plus 1. Since we have used the same number of stones 2 times, that's why we have to divide it by 2. N into n plus 1 divided by 2. So that is how the game of rocks can be helpful. But being very profound in their, or the very logical in a way of expressing itself, mathematics is occasionally insecure. When it will be insecure, there are some examples that I want to discuss, a few examples where mathematics feels very insecure. Say, for example, this one. 1 minus 1 plus 1 minus 1 plus 1 minus 1. So what will be the answer for that? I don't know how many ones are there, how many minus 1 ones are there. But there can be 2 ways of arranging them. What we can do is that we can arrange 1 with minus 1, 1 with minus 1, pair them up, I will get 0. If I leave 1 aside, then start from the second, minus 1 with 1, minus 1 with 1, I'll get 1. So these are the options. You can see that there will be many more options. Now, then what is the true answer? What is the true answer to this question? Another example is this. Suppose there are two concentric cycles. And let me draw a line from the center that intersects both the circles, inner circles as well as outer circle. In how many points this particular line will intersect in the inner circle? In how many points it will intersect in the outer circle? One each. In that way, what we can conclude is that the number of points in the inner circle is same as the number of points in the outer circle. Then if number of points in the inner circle is same as the number of points in the outer circle, the perimeter of the inner circle is equal to perimeter of the outer circle. But we know that for two different circles having different area, we cannot have same perimeter. So where is the mistake? So the mistake in either of this problem is because of the idea of or a lack of idea of infinity. We can see that, as I have already mentioned, that as long as how many is the answer to how many is finite, we are well and good. But if it goes something towards uncountable or infinity, then will not be in a very proper shape. Your logic fails in many ways. So these are two examples where we fail. Then one example that I think I should drop this because it may. Okay, let us try. So Hilbert has come up with an idea. Suppose I have. It's a very you can say unique hotel where there are infinitely many number of rooms, and the hotel is designed in such a way that it can accommodate any number of guests. How can you do that? Suppose in the very beginning we have almost, all the room assigned to some persons. So infinite number of persons have been assigned to infinite number of rooms. Again, a set of infinite number of passengers come. Then what we will do? How can we accommodate these new passengers? These new, you can say, guests. So the way to accommodate the new set of guests, what we can do is that we can move every person to a room twice of his number. Suppose the person was at a room having room number X, then he will be moved to 2X. If he was at room number 2, he will be moved to 4. If he was at room number 3, he will be moved to 6. If he was at room number 5, he will be moved to 10. In that way, what we can do is that all the odd number of rooms will be vacated. 1 will be moved to 2, so 1 will be vacated. 3 will be moved to 6, so 3 will be vacated. 5 will be moved to 10, so 5 will be vacated. In that way, all the odd number of rooms will be vacated. And how many odd numbers are there? We have infinitely many odd numbers. So now we can accommodate whatever infinite number of guests to these n numbers. But there is a twist. The twist is that if we have infinite number of buses containing infinite number of passengers in each of the buses, then what will be the solution? What will be the solution? Keeping in mind that the waiting time has to be finite. We cannot keep a particular passenger wait for infinitely many times. Because if we want to do the same thing for the first bus, it will take infinitely many times. Then only you can start accommodating the passengers from the second bus. So only when the first bus is completed, we can go for the bus number 2. So that is the challenge, and it will take infinitely many time. That's why the waiting time will be infinite, and obviously the guest will not be very happy with it. So what is the solution? Here comes the idea of comparing infinity. What Cantor has proposed is that to infinity, there are some infinities which are larger than some infinity. But it was at that time ridiculed by many of the mathematicians. They said that it is not possible. It's a very bogus idea. You cannot compare infinity. We cannot compare infinity. We cannot say that one infinity is larger than the other infinity. But it was proposed by Hilbert, this hotel problem, only to make people understand that, yes, there are some infinities which cannot be handled. And there are some infinities which can be handled if we do it in a proper, in a systematic manner. And Hilbert also commented that people in future will give a space in the world created by Cantor. So it was a very famous quote by Hilbert, that Hilbert believed that it was their fault. It was their fault that not to believe Cantor with the idea that two infinities cannot be compared. But yes, there are some infinities which are very large to handle, larger than some other infinities to handle. So that idea of Cantor proven to be correct. That's why Hilbert says that it is a Cantor world. It's a beautiful Cantor paradise. And I hope that people in future will give some space to us to be there in the paradise created by Cantor. So it's a very famous story. You can always read this story. It was very heartwarming story. Now the question is that what happens if number of buses coming with passengers marked in real numbers? Like now we are marking the passengers as 1, 2, 3, 4, 5. This is the first passenger, second passenger. Suppose if I mark the first passenger as 1.1, second passenger as 1.1.1, third passenger as 1.1.1, 0.1, something like that. So what will be the procedure to accommodate all these passengers in the Hilbert Hotel? Will it be possible? Here comes the idea of what is called the uncountable sets and or the truly infinite sets. Okay, now what are the challenges in teaching this mathematical ideas? This is very hard because we have to balance the rigor as well as we have to be very creative. This is a very difficult thing because we cannot relax the concept. We cannot get away from or deviate ourselves from the rigor that is required to understand a particular concept just by trying to be creative. So that is very difficult. We cannot just go away from the rigor of mathematics. Second thing is that so many concepts in mathematics are very abstract. So it is very difficult to make it accessible to all the students. I'm also facing this problem. That's why I'm just sharing with you, because there are some concepts which are very abstract. It is not easy to make them, make a creative way to make it possible for the student to understand the concept. It is the rigor that is required to understand this concept. And sometimes if you try to be creative, we lose the idea of, or we lose the concept, the very rigor of the concept. And what we can only do is that we can encourage our student to see why behind every mathematical method. So we see that mathematics is not just a procedural way of understanding a particular sum. It is not only the procedure, but why this procedure is applying, why it is doing in this way. So that is very essential to understand for a student. If that student wants to be creative, he should be allowed to be creative, but of course with a balance of rigor and creativity. In conclusion, what we can see from this, I hope that I can convey my very, you can say, preliminary idea of mathematics as a discipline of both art and science, and how it is rooted in deep epistemological questions. And teachers play, of course, a crucial role in nurturing students' understanding in these dimensions, because as I have already mentioned, that they are a very level of understanding. Once we go deeper into the topic, we will need more rigor to understand the concept. So that is the duty of a teacher, to not only relax or not only to make it simple for the student, as Einstein always says, that make it simple but don't make it simpler. Always try to balance your creativity with rigor. And thank you for having me. This is what I want to convey in this half an hour or 1 hour talk. Thank you for listening. And these are some references based on which I have prepared the slides. Thank you. And this is our university. This is my email ID. I'll be very happy, especially students, I'll be very happy if you drop a mail with any query. I'll be very happy to address. Thank you.
Thank you. Thank you very much, sir. Sir, this piece is really highly encouraging, informative, and it is really captivating. Even a layman, I mean, a person without having any mathematical background can easily comprehend and can get all the valuable insights that you have tried to express through this talk. So first of all, I would like to
Thank you, Surata.
ask, is there any student? If anyone have any query or question, you can ask. Sir, I think since it is holiday and the students are maybe they're
It's okay.
joining, and
It's okay.
but
Yes.
it is really, sir, it is interesting. I have gone through a book. It is Topology Through Inquiry. It is by Mitchell Sturbard. Yes, I think.
Yeah.
And there I have got such kind of things, how to engage students in mathematics and encourage them. And actually I was searching, looking for such types of presentation. So in class also, sir, apart from introducing the syllabus and completing them, we, all the teachers, we know we have to give some time to make them understand what is paradox, what is corollary, what is lemma, theorem, and all. And you have started with God, and so beautifully you have explained about this limit, area, about infinity. It is really engaging and encouraging, sir. So we have YouTube recording of your presentation, and I will be definitely sharing it with all the um, uh, all who I know, those are interested in mathematics. Thank you, sir. And we definitely we will try to arrange some program to, and we hope you will be there with us in Gorgaon College, sir. Thank you,
Yeah,
sir.
I'll be very happy to be there in your
Yeah.
campus. Yeah.
Yes.
So the thing is that in social science, what we have is that we have the problem in our hand. We can see the problem in the society. So it is very
Yes.
easy to understand for the students, at least the problem, nature of the problem. But with mathematics, the very problem is that the problem it cannot be understood sometimes,
Exactly.
because it is not
Yeah.
in front of them. But
Yes.
if we try to make it very, I mean, if we want to present it in a very creative way, at the same time, we should be very careful so that we should not lose the rigor of the problem. So that is very important. That is my understanding
Exactly.
about mathematics. Yeah. So it is
Yes,
difficult. It is difficult, but it is not that difficult. If we try, you
yes.
can do that, in fact. Thank you.
Yes, thank you, sir. So in this occasion, so I'd like to take the privilege, sir. Actually, there is a thought in my mind that during while I teach students the mathematics, degree level mathematics, what I really do feel is that it is important to teach them how to learn mathematics. along with the syllabus of
Yes,
course we have.
yes. That's why
Yes.
I was just telling you that why is very important. A
Yes.
student may not know what is group, but once he know this is a group, once he know it is an abelian group, why it is so, that should be inquired by the student.
Exactly.
That is my point.
Yes, so we will definitely try to have you in our college, sir. Thank you, sir. Yeah, thank you. Yes. So here we are almost towards the end of our talk, and now I would like to offer the vote of thanks. So first of all, I would like to thank respected principal Dr. Sebasati Mahanta sir, Vice Principal sir Diganta Kumar, HOD of Nazira College Jiten Fukan sir, IQAC coordinator of our college Surajit Soikia sir for their suggestion and support. Next, I would like to extend my gratitude and warm regards to the resource person, Professor Varali sir. Really, today we have very engaging, informative, interactive session with him. And I would also like to thank all our respected delegates, the teachers present here in this occasion with us, the students, and last but not the least, I would like to thank our organizing committee, especially my colleague and my friend, Mr. Hare Krishna Mili, Kavita ma'am, and Surajit Soikia sir. They all have actively helped us in all the technical parts to make this event a successful one. And with this, I would like to also thank all the other persons directly or indirectly help us to complete this session, this event. With this, I would like to declare the end of this session. So today is Holi. At the end, I would like to wish you everyone happy Holi, and we will definitely be having such session again in future. Thank you everyone.
Thank you.
Thank you, sir. Thank you. Ma'am, আছেনে?
আছো ধন্যবাদ স্যার স্যার আমি
হয়।
অফলাইনত আকৌ লগ পাম
Lily,
বুলি
thank
আশা
you.
ৰাখিছো আপোনাক স্যার ভৰলি স্যার হেল্ল'
তেওঁ ওলালে
ওলালে
চাগে
ন?
হয়
ঠিক আছে
ঠিক আছে মেম মিটিং এণ্ড কৰি দিছো মেম
সুজাতা
মেম এইটো হেৰি কেনেকে কৰিম যে এণ্ড
মই সৰজিতলৈ ফোন কৰিছো ৰবা ঐ আমি এণ্ড কৰিব পৰা নাই নহয় আমি লিভহে কৰিব পাৰিম তুমি এণ্ড কৰি দিব